This video is going to take us through perfect square roots, cube roots, and the approximations of roots. So the first part is we're going to talk about the perfect square roots. Again, this is kind of a review. It's again the same number times itself. So if I have the square root of 9, think of 3 times 3, so the root is 3. For perfect cubes, same number times itself 3 times. So if I have the cube root of 64, we want to think 4 times 4 times 4. So the root is 4. We're just coming up with an answer with 1. So the square root of 16 would be 4. So if I take 4 and square it, I get 16. Cube root of 125 is 5. Square root of 81 is 9. And the cube root of 343 would be 7. One of the other things that we can throw in here is roots of fractions. We want to do this in parts. So if you're given a big problem like this of the square root of 4/25, we don't want to try and think, oh, I got all this stuff to do. I want to just think in separate of, okay, well, what's the square root of 4? Well, that's 2. Square root of 25? Well, that's 5. So I end up with a fraction of 2/5. So again, we're just doing it in parts of something that we've already done. So cube root of 216 over 343. Well, the cube root of 216 is 6. Cube root of 343 is 7. So we end up with 6 sevenths. So square root of 36 over 49. Again, they're perfect squares, so it's 6 sevenths. Our last example is cube root of 64 over 1,000. So we have 4 over 10. And you may want to reduce that if they ask you to. If not, we'll just leave it as that. But we'll probably have you reduce it as we go. So nothing too difficult in this part. It's just you're doing it in different sections with the roots. Part that's going to get a little tough is the approximates. These are not exact. We're kind of guessing where we're going with the number, close to or between. So these are some of the things that you'll see in the directions of the problem. Again, the perfect ones are rational numbers because you come up with a whole number or a rational number as a part of the real number system. These, however, are the irrational ones. These are the ones that don't repeat and there's no ending to them. So there's no pattern in the number as they divide. So what we're going to do is we're going to kind of find the approximate value of this without using a calculator. So no calculators in here. So how this plays out is this. They're going to ask you what two numbers will the square root of 17 fall between. So how you want to think of this is two numbers. If I square those two numbers, would 17 fall between them? So if I take 4 squared, I get 16. That's less than 17. And 5 squared, which is the next number in series, and I take that, that's 25. Well, 17 fits in between. So it's 4 squared is 16, 5 squared is 25. Our 17 fits in between. So the answer of the approximate would be it's between 4 and 5. And that's what we're looking for. So if we look at some of the other examples, if I give you the square root of 35, what you want to do is think about, well, if I take 5 and square it, it gives me 25. If I take 6 and square it, I get 36. So that puts us in between 5 and 6. Again, it's not an actual answer, it's an approximate. So in a way, we're kind of guessing at what we're trying to find. We can do it for cube roots as well. So if I take the cube root of 234, in this case, we're going to think of 6 cubed, 216, and 7 cubed, which is 343. Well, it fits in between 6 and 7. So our answer would be 6 and 7 for our number that we're looking for. Our last example is the square root of 155. So it falls in between 12 and 13 because if I square 12, I get 144. If I square 13, I get 169. So somewhere in between 12 and 13, it's going to fall for the square root of 155. We don't care what it actually is. It's just an approximate value. So as we go on with this concept, we're going to look at between which two consecutive integers, meaning consecutive, meaning in order as they go, and we've already kind of been doing that, is the square root of 27. So again, we're going to think of two numbers. We're going to square them. And would 27 fall in between once we square those numbers? So once you find the first one, the second one is just the one next in order. So if you find that the answer is 4, it's going to be 5. In this case, it's 5 and 6. It falls in between those two. So our answer is it falls in between 5 and 6. So again, approximate, not the exact. So even if you had the cube root, if I had to take the cube root of 286, it's going to fall in between. I know if I square 6 cubed, it's 216. That's lower than this, which is what I want it to, because it's going to fall in between. Well, the next number past 6 is 7. And if I square 7, it's 343. And again, that falls in between there. So again, 8 cubed, or my example is this cube root of 585. So it's going to fall in between 8 and 9. So our answer would be 8 and 9 because that number falls in. If I cube 8, if I cube 9, somewhere in the middle here it gets to be where it's at. So that's all we're doing with this as we go through it. So we don't want to take too much and make it too complicated. We want to just kind of keep it pretty simple. A couple other things that they're going to use is greater than or less than symbols. Less than pointing to the left, greater than pointing to the right. So in my case of square root of 29, I have this falls in between 25 and 36 because I squared my 5, squared my 6. So as we read it, it's 5 is less than 29, the square root of 29, and square root of 29 is less than 6. So most of the time, your signs are going to be pointing in that direction. So again, read as 5 is less than 29 and square root of 29 is less than 6. And we can do this for cube roots as well. So again, we're looking at what does it fall in between. Well, this is less than this, but this is less than this. So that's where these less than signs come in. They're all pointing to the left, so we read it from that direction. One of the other things that they're going to do is they'll throw negatives out in front of it. Well, when they throw negatives out in front of it, they're looking for the integer part. So what integer? Now this is a little bit backwards because if you look, now my bigger number is first, my smaller number is second, but in this case they're negative. So the square root of 11 would fall in between a -4 and a -3. Well, if I square a -4 and I find the opposite of that, that's -16. If I square the 3, it's 9, but the opposite is -9. So these are what I'm looking for. This is where it falls into play because I would find the square root and then my negative would come out because of the opposite. But remember, the larger the negative number, the smaller it actually is. So the larger number for your negative number, it's farther away from 0 that you go. So if I look at the negative square root of 65, it's going to fall in between -9 and -8. So in this case, my larger negative goes first, followed by my smaller negative, and we're, again, doing it in consecutive order. So it's a little bit backwards from the other one because as we go away from 0 to the right, we get larger. As we go away from the 0 to the left, we get smaller. So it's kind of backwards in the sense of thinking how my numbers work out. The last part is probably the most difficult part of this, and that is when we have to find the approximate to the nearest 100th or maybe to the nearest 10th. This is where you're going to kind of have to guess a little bit and see where it falls in. So we know if we get the problem of square root of 21, the first thing I want to do is find out where it falls in between. So in this case, it falls in between 4 and 5. Well, if I square 4, I get 16. If I square 5, I get 25. So I know that it's somewhere in between here. So I know it has to have the whole number of 4 point, and now this is where this part of this comes in. Where does it kind of fall in? Well, if I take a look at it and in a sense look at it on a number line, my tenths number is going to be where does that fall from that number to the next? So in this case, it's almost halfway, a little bit more towards the right of this, towards the 25. So that's where the 5 would come in, and then this one you're going to have to multiply. You're actually going to have to take 4.5 and then pick a number of where you think that would fall, and then how does that come close to 21? You're not going to get the exact number, but that's going to be the tough part. So this last one is kind of the guess of where you're at. And basically both of them are kind of a guess on that as well. So if we have the square root of 99, our biggest thing is what does it fall in between? From there, we're going to look at it. If I do come up with the numbers, notice how 99 is really close to 100. It's only one away. Well, when I look at that, the closer I get to that next number that it's between, that's where this 10th spot starts to get higher. So I know that it's bigger than 9, so 9 is my starting point. My decimal is now, where does that guess come in? And again, when I start looking at this, it's 9.9, because 0.9 would be real close. It's almost to that next whole number. The 0.05 or the 0.95 here, if you look at it, again, you're going to have to actually just take 9.95 times 9.95 to come up and see how close that gets you to 99. And that we have to play around with this in class a little bit. The last example is the square root of 83. Again, we're looking at where it falls in between. That's kind of the first part of this. And then the second part is kind of more the guessing section. 9.1, because 83 is closer to 81, so we're going to be more closer to the 9 part of this. So that's why this number is less. And again, it's still closer to 81 than 100 is. So my next number would probably be smaller as well. But again, it's where you got to guess a little bit on this, which is the perseverance stuff where we got to try it more than once. This part really works well with multiple choice because you can kind of get an idea by the whole numbers of where this would fall. So again, we'll probably play around with this in class as a group and see how well we come out with it and just kind of play with it a little bit. But other than that, there's your next video on roots.